Hmm. So what this is a beginnings of a perception system that I'm putting together using CARLA simulator and its Python API, as well as a YOLO detection model. So really, the the goal of this series is to develop an advanced driver assistance system. And this is really just a simple baseline of a uh, YOLO model working that's already pre-trained on a general purpose data set. And right now it's being fed in frames from an RGB camera that's attached to a car in CARLA simulator, and it's taking those pixels and it's using that to draw bounding boxes on these frames. So really, what is CARLA? So CARLA, CRALA, is a simulator that is used for autonomous vehicle research or developing self-driving cars. Uh, and the reason why this is useful is because it's much cheaper, it's much more affordable to use a self-driving car simulator like this rather than a real vehicle. And the reason why is because of costs. It's easier to experiment and integrate, and many more reasons why. Uh, so so the camera, you're probably wondering, how does the camera really connect to the YOLO detection model? Luckily, I have a diagram shown right here. So first we start off in the CARLA world, and the way CARLA works is built off of the Unreal game engine, where you have to uh, look at potential blueprints, really, of how things are built. And CARLA works off of this thing called the they have like a system of actors that you would spawn in that's based off the blueprint. Here we have a spawn-in ego vehicle. That's the main vehicle that we're following around with cameras. Is how we're going to interact with the CARLA world. Here we have the RGB camera sensor. RGB, red, green, blue. It's a term that's used for a basic camera. We're just spawning it in, and then we're going to be attaching it, and then it's going to be streaming these frames, each of these frames, and then it will be processing those frames into a raw pixel numbers that will be fed into the pre-trained YOLO model, which is a convolutional neural network. And what it will do is it will take all of those numbers, which is essentially a matrix of pixels, and it will output these raw detections. And most of these detections will get filtered out by a confidence threshold. Uh, in the code, we have zero point 0.5 just to get something started. Uh, Many perception systems that are used might have something higher, like zero point 0.8 or zero point 0.9, depending on how good the model is. And then much of these detections get filtered out and tossed out, like I said before. And then the result will be a bounding box with class labels as well as the confidence level and a visual overlay of the drawn bounding boxes for the RGB image. So now that has been discussed, I'm going to discuss the computer vision pipeline. So for the computer vision pipeline, what's really going on is in this code here. So as you can see, most of this code there seems to be quite a bit. Most of it's commented out, and quite a bit of it is really just importing your modules and declaring variables, spawning your actors, importing your blueprints, um, attaching the camera to the roof of the car. But really, the computer vision pipeline starts right here, where the camera is listening, and it's looking at this method that is declared earlier called process image. Now, to scroll back up here to process image, we have our global variable, which is the latest frame. And then we have this little line of code here that converts the raw sensor data from the camera into numbers for the YOLO model. So this is the raw numbers here, and then it basically converts this into a bunch of integers. And then what this does here is it reshapes it into a matrix that does not include the alpha channel, but just has the red, green, and blue channels. So that sounds a little bit complicated, but it's a little bit easier when you can kind of look at it and see what's going on. So I'm gonna cut the script real quick, and then we're gonna run it again. So script again. So every single one of these truncated matrices is a oh, you probably can't even see the screen. So each one of these truncated matrices is it's really one image that is drawn from the RGB camera. And every single one of these three values is 1 pixel starting at the very top left of the image that's captured. And then it typically goes from left to right, and then it starts on the next row and it goes left to right. So this image is 640 by 480. It goes by the width and then the height. So there's about 640 by 480 of these um, 3-digit numbers for the red, the green, and the blue. So all these numbers are being processed and fed into the YOLO model for object detection. Really, the YOLO model, which is where it's being fed in here, the latest frame for object detection, it doesn't know that it's looking at frames from CARLA. It just sees the raw pixel values, and then it detects the object classes, the object location, the confidence scores, as well as the you know how should the bounding box be drawn. So that's what's going on here. These are the results, and then it typically gets drawn on the screen here. So that's what's going on there. Let's run the script again. There you go. Sounds very good. So what's really good about this YOLO model, what's very impressive is that it was able to detect objects. It could locate them. It can see like, hey, this is a person. That's a car. One downside of this is that it doesn't have persistent tracking across frames. So what does that mean? You might see quite a few flickering bounding boxes for cars that are driving by. Like there might be a bounding box, and then there might not be one, and then there might be one again. The YOLO model thinks that that is two different cars, when in reality that's just one car. So this is an issue because in any ADAS system, automa- automated driver assistance system, there is a a need for tracking objects over time. What this will do is it will be a way to predict motion and kind of estimate where objects were going in the frame, and really provide more valuable information than just say, hey, there's a person here. Hey, there's a person here. There's a new person here. When in reality it's just one person that's moving towards you, or might be um, moving faster towards you, and you need to slow down. So that's what will be worked on next week. It will be developing an object tracking system with persistent IDs for each tracked object. Um, right now, it's a pretty decent start with detected objects, but it's not consistent yet. So, thank you for watching the video, and see you next time.